So, hi everyone. It is our second video of our channel, Science and Mathematics, and today we will discuss on metals and non-metals. And today we will have our topic that is on the reactivity series and the chemical properties of metals and non-metals. Okay, it is a very important portion of metals and non-metals, and in our previous video we have already learned about the physical properties as well as their occurrence as well as their characteristics by which we can consider a material or element to be a metal or non-metal. So we have learned the introduction to metals. Now today we will do our reactivity series of metals and also the chemical properties of metals. Okay, now metals and non-metals, a channel that is science and mathematics. Okay, now it is a very important chapter. As I told you, it is an important chapter. The whole chapter that is of metals and non-metals is very much important. So without wasting any time, let's start. So what is this reactivity series? Reactivity is, as we know that we have learned in our earlier classes, that some metals are very reactive, whereas others are less reactive and some are unreactive, right? So if we take an example of metals which are very reactive, we can take the examples of potassium and sodium, which reacts vigorously with cold water, and it also reacts with the air. Okay, so we can consider it to be very reactive metal. Okay, now some examples, that is of zinc and iron, they react only with steam, that is in the vapor form. So we can say that they are quite, so zinc and iron are quite unreactive. Okay, now on the basis of this their displacement reaction, their properties, when they react with elements or compounds such as oxygen, oxygen, water. Water is which is a compound of H2O. Okay, now it also reacts with acids. These are the properties on which this reactivity series is totally based. Okay, this this react this reactivity series is totally based upon this reaction with these properties. Okay, various metals with oxygen, acids, as well as displacement reaction. Now we will learn that what is the sequence in reactivity series. It is from higher reactivity to lower reactivity. Okay, now we will see a image of the reactivity series. Okay, now let's move on to our next slide. So this is a reactivity series of metals. Reactivity series, this series consists of mainly the common metals which are used in laboratory. Okay, it is from higher reactivity to lower reactivity. That is, we can see that the potassium, sodium, calcium, magnesium are the main reactive metals. Okay, and below hydrogen, these are called non-reactive metals or unreactive metals. Okay, they are very much less reactive. Okay, now above the hydrogen, they are very reactive metals, and below hydrogen, these are non-reactive metals. Now we will learn about the chemical properties of metals and non-metals. First, we will learn metals in this video. Okay, now probably at the time of revision before the examinations of your school internal examinations of your school, we will also learn about the chemical properties of non-metals. Okay, now what is this chemical properties? This is what the reactional properties or also the displacement reactions. Okay, now we will first learn the reaction with oxygen. So in general, metals form oxides. Okay, when combining with oxygen. Okay, when they combines with oxygen, they form metallic oxide. They form metallic oxides. Okay, now sodium, potassium burn in air. As I told you before, that sodium and potassium are very reactive. They react vigorously with air as well as water. Okay, so they are kept in kerosene to avoid their reaction. Okay, now the aqueous solution, that is when you can see this line, that is aqueous solution I have written. You can also write aqueous solution, that is when water is added. Okay, aqueous solution of these oxides are alkaline or basic in nature. Alkaline means is those bases which are soluble in water. Okay, that is the alkaline term used for those bases which are soluble in water. Okay, now let's take an example, that is when magnesium bonds in oxygen, we know that a white flame is formed. Okay, now this now before I want to tell a thing that is you will find in the book, NCRT book of class 10, that is there is a question that why magnesium is rubbed or by a sandpaper before burning with oxygen. The reason is what is it is to remove the layer of magnesium oxide which gets formed naturally. Okay, it is only to remove that layer. Since it is used, there is a question that why magnesium is rubbed with a sandpaper. So it is the answer to this question. Okay, now when magnesium reacts with oxygen, it forms magnesium oxide. Okay, this 2 Mg plus 2 Mg plus O2 and plus 2 Mg, it is only to balance the equation. Okay, now when magnesium is tend to react with water, you can also say it forms magnesium hydroxide. Okay, now this magnesium hydroxide is alkaline in this magnesium oxide is alkaline in nature. Okay, now this magnesium oxide solution changes red litmus to blue, indicating that the solution is alkaline. So there is a concept we all know, that there are some indicators like turmeric, then penophthalin, then others such as sorry, their litmus paper. These are the indicators. Okay, and also there is a called methyl orange. There is a these are the indicators by which we can say that a metal or sorry solution, or a you can say that it is a solution. When solution we have to find out that whether it is an acidic medium or a basic medium or neutral medium. We can use these indicators to find out this. So in this regards, I wanted to tell you that many students I have seen that they get confused between the litmus papers change. Okay, that which paper acid will change, which paper to paper, which color to color, basis will change. Okay, now this is the answer. This I will give you a short trick on this. That when you have been said that this solution is acidic, so you take the D of acid. Okay, you take the D of acid. Now there is also red in the red D. There is also D in the word red, and there is D in the word acid. So we can understand acid will change litmus paper to red litmus, red color. So it will be it obviously it will be blue litmus to red, because it is changing to red, then it obviously it will be blue litmus. Okay, and in case of base, you take the word you take the alphabet B in base, and it is blue in B. Okay, it is also there in blue, so we are understanding that it will change red litmus to blue. It is a short trick. You can use this trick to find out that acidic solutions or basic solutions change which litmus paper to which color. Okay, now this is a short trick. You can try this. Okay, now similarly, non-metals or reaction with oxygen from their oxide, but on adding small amount of water to this solution, they become acidic. So here what we can see that when non-metals are tend to react with oxygen, they form oxides. They also form oxides, but those oxides are acidic in nature. Okay, so this is a point of difference. We can say that when the non-metals react with oxygen, they form acidic solution. Okay, sorry, not oxygen, with oxygen, then after with water. Okay, this forms acidic medium, and in case of not metals, it forms basic medium. Okay, now take an example, that is S is sulfur and O2 is oxygen, then it is forming sulfur dioxide. Okay, now when sulfur dioxide reacts with water, it forms sulfurous oxide. Okay, it forms sulfurous oxide. Okay, now it is for chemical formula is H2SO3. Okay, now the solution of H2SO3 turns blue litmus to red. So as I told that it was acidic, and I told that acid, if you take the D of acid, and there is also D in the word red, so we can understand this, it will change litmus paper into red. So it will obviously change blue litmus into red. Okay, so it is acidic solution. So the point of difference are getting based on the reaction of with O2 is that metallic oxides are basic in nature, while the non-metallic oxide are acidic in nature. So this is a point of difference we are getting here. This is the point of difference we are getting from this reaction. Okay, now let's move on to our next slide. So reaction, it is reaction with water. So first point, there is different metals have different behavior while reacting with water. Okay, some metals react vigorously with cold water, like I told you, gave you the example. In previously I have given you the example that the sodium and potassium react vigorously with cold water. Okay, and some metals react with steam, such as magnesium. Okay, magnesium reacts with steam. Sorry, magnesium. Sorry, they. Sorry everyone, magnesium reacts with hot water. Okay, I told it wrong. Magnesium reacts with hot water, and the iron and zinc, they react mildly with steam. Okay, now let's move on to our next point. Sorry. Okay, now sodium reacts violently with water. Okay, to form sodium hydroxide, and this reaction hydrogen gas is liberated. So in case of metals, okay, in case of metals, hydroxide are formed. Okay, hydroxide and forms are and hydrogen gas is liberated in this case. Okay, now here I have given you the reaction that sodium, two ions of sodium, and then water, and then it is forming sodium hydroxide, and hydrogen gas is liberated in this reaction. So magnesium virtually has no reaction with cold water, but it reacts vigorously with hot water. Okay, so magnesium reacts with hot water. So in when you are giving this example of magnesium, you can also write in bracket of H2O, you can also write that hot. Okay, you can also write hot because it is hot water. Now likewise, zinc and iron react vigorously with steam, whereas copper, silver and nickel do not react with water. Copper, silver, nickel are metals, but they do not react with water. Okay, and now zinc and iron, we have understood that they react vigorously with steam. Okay, now the important thing is non-metals do not react with water. That is why phosphorus, which is a non-metals, react vigorously in presence of air. To avoid reaction, phosphorus is kept in water. So here what we can get, that non-metals and do not react with water. Sometimes we get question that when non-metals react with this hydrogen gas is liberated, true or false. Sometimes we get this question in exams, so it will be totally false because non-metals do not react with water. Okay, now phosphorus is kept in water because non-metals do not react with water. Okay, and we know that phosphorus is a very much reactive non-metal, and it reacts with air. Okay, now so it is kept in water to avoid that reaction. Okay, so let's move on to our next slide. So now we will learn about the reaction with acids. So in reaction with acids, metal when reacts with acid, from metallic salt of the acid and H2 gas is liberated. Okay, now they form metallic salt. Okay, they form metallic salt. Now aluminium, iron and copper when react with dilute hydrochloric acid, okay, aluminium and iron form AlCl3, okay, that is aluminium chloride, and FeCl2, that is ferrous. Now, so aluminium forms aluminium chloride, and ferrous also ferrous chloride. Okay. Now, respectively, they form this type of salts. These are the salts as we were talking about this, but these are the metallic salts. Okay. Now, hydrogen gas is evolved in both the cases. Okay, but copper doesn't react with dilute hydrochloric acid. Okay. Now, let's take an example that copper does not react with anything that is dilute. Okay, dilute means what? Dilute means where there is water, or you can say that aqueous solution. Okay, it is means dilute. Okay, copper mostly don't react with doesn't react with the dilute solutions, such as it also doesn't react with dilute sulfuric acid. It mostly reacts with the concentrated one, okay, in which the acidic ions, okay, the OH plus ions, you can also say OH ions are there, okay, they react in which there is a more number of OH ions, they react with that type of solution. The copper reacts with that type of solution only. They copper react with concentrated sulfuric acid and concentrated nitric acid. Okay, now let's take an example. Why not? It reacts with concentrated and sulfuric acid. Now example, 2 aluminium, it is only to balance the equation as I told you, plus HCl, it forms aluminium chloride, and 3 ions of hydrogen gas, or you can say it is evolved. Okay, now Fe plus HCl, it is from ferrous chloride, and the H2 gas is evolved. Now normally non-metals do not react with acid, okay, but sulfur is the exception that it reacts with acids. Okay, now S plus 4 HNO3 equal to SO2 plus 4 NO2 plus H2O. Okay, HNO3 is the nitric acid. It is a nitric. HNO3 is the nitric acid. Okay. Now I will give you an example over this nitric acid, that HNO3, when it is very diluted from N2O. Okay, and then when the HNO3 is concentrated, it form NO2. Okay. Now when HNO3 is dilute, it form NO. Now you will have a question in your mind that, so what is this N2O or this? Okay, now this N2O is nitric oxide. Okay, now NO2, this is nitric, NO is nitric oxide, and NO2 is nitrogen dioxide. Okay, when anything reacts with concentrated HNO3, it forms NO2. Okay, that is nitrogen dioxide. Okay. Okay, and this N2O is nitrous oxide. Okay, now I am writing it on my screen itself. Okay, you will be clearly you can see this. Okay, let me write it on my screen. So I was talking about first one. 1 minute. I was talking about the first one, when HNO3 gets reacted by when HNO3 is very dilute. Okay, HNO3, that is nitric oxide, when it is very dilute. So what it forms? It forms N2O, that is nitrous oxide. N2O is nitrous oxide. Okay. Now when this nitric oxide is concentrated, when this HNO3 is concentrated, okay, when this is it is dot here, conc, then dot, it is write as concentrated, then it forms NO2, that is nitrogen dioxide. Okay, it is nitrogen dioxide. And when the nitric acid is very dilute, that is dilute, it is only dilute. Okay, when it is only dilute, that is DIL dot. When it is only dilute, it forms NO, that is nitrous oxide. It only forms NO, that is nitrous oxide. Okay, now we have learned this. Okay, now let's move on to our next slide. Okay, so metal replaces metal. So it was the displacement reaction that I was talking about. Okay, I was talking about the displacement reaction. So what is it? A metal can replace another metal from its salt solution. Okay, suppose copper sulfate we know as salt solution. It can the ferrous or iron can replace it, because if we check out this reactivity series. Okay, if you check out this reactivity series, 1 minute, if you check this reactivity series, okay, you will find that copper is below the ferrous, so it is reactive than copper. Okay, so it will surely displace. It is according to the reactivity series, the displacement reaction totally depends upon the reactivity of metals. Okay, now if we say that if we are given that zinc sulfate, and you are given that ferrous will replace it or not. Okay, now your answer will be no, because zinc is above iron. You can see here that zinc is above iron. Okay, zinc is above the iron. You can clearly see that here is zinc, okay, here, and iron is here, so it is more reactive than zinc. Okay, it is clearly understandable. It is more reactive than zinc. Ferrous is less reactive than zinc, so it will be not. Okay, now I have given you some example like this only. Okay, like magnesium replaces copper from copper sulfate solution like this. Higher reactive metals, higher reactive metals. Sorry everyone. Reactive. So the reactive metals replaces the other less reactive metals from its salt solution. Like you can see this example that when ferrous we are getting reacted by this copper sulfate solution, it gets from ferrous sulfate or iron sulfate. Okay, and copper it gets in most books it is written as precipitate. Okay, it is the precipitate. It forms at the bottom of the tube, or sorry, not tube, it's you can say the test tube. If you are taking a test tube, it will be at the bottom, and you can also take a boiler, not a boiler. Okay, it is called the beaker. Okay, beaker you can also take for this reaction. Now it is magnesium. Okay, you can see this example that magnesium when reacts with copper sulfate, it forms magnesium sulfate and copper. Like this it gets formed. Now let's move on to our next slide, that is what is alloy. Okay, alloy is what? Alloy uh, alloy is, it is a mixture of different metals, a metal by combining or two or more metallic elements. Okay, it is by combining more than two metallic elements, two or more than two. Okay, especially to give greater strength or resistance to corrosion. This is the main points of this, why what is alloy and why ores are formed. That is what is the reason that greater strength, it is to give the greater strength and resistance to corrosion. Okay, and some examples are brass and solder alloy. Now we will take some example. So alloys are made of combination of two or more metals. Okay, some alloys are the metals which are used to prepare that are mentioned below. So it is the list. You can see that brass there is copper and zinc, and also a small amount of tin, that is Sn is also there. So copper is there in 66.56%. You have to remember this percent also comes in exam sometimes. Zn, okay, 37.01%. And what is this uses of brass? The uses of brass is it is used in musical instruments. You also know, I hope you have seen the utensils there, brass is also used. Okay, now it is also used in ammunition and also plumbing. Okay, and it is also used in electronics. Okay, now in bronze, take the example of bronze, which is a very common. In this, copper is there of 88% and tin is there of 12%. Okay, now it is boat, ship fittings, propellers, submerged bearings. These are the examples. Now you can see the list. Duralumin, there is aluminium and copper. Okay, and small amount of magnesium and silicon is also there. You can see this example. Okay, like the solder alloy I was talking about, there is lead and tin in and also, okay, there is lead and tin, and there is also calcium. Okay, there is also you can also see that the in the solder alloy, bismuth is also used in that is 42%. You can also see this examples, and as I told you that if you want this presentations, okay, if you want this presentations, I will share with you. You have to join my Google Classroom. Okay, you can check out the code. I will give you in the description box. Okay, you can join there my Google Classroom after subscribing my channel. Okay, that is science and mathematics. You can subscribe my channel and get to there, and you will get all study materials there, my all presentations you will get of each chapter. So this is our end of the video. This is the portions we have covered in this presentation. Okay, the chemical properties, the alloys. See, so thank you everyone. See all of you in next video. Thank you.